Yeah, yes, yes, we can. Hello, guys. Welcome you all for this end-to-end AIML session where we're going to learn everything to become a successful data scientist. So, guys, as we are mentioning always, please go through all the previous session videos so that you can have a better understanding of what we are telling. So, guys, we are very excited and we are giving lots of content. We have just walked through lots of things like a basic thing and then from coding. Now we are just moving on to a new domain, like new thing, like a machine learning kind of thing. Okay. Hope you guys are enjoying. Today we will say one more category in machine learning, which is supervised learning. Inside supervised learning, we're gonna see a different category, that is classification. In the previous session, we have discussed about regression, right? Today we're gonna discuss about classification. Okay, so guys, if you guys have any doubts, any queries, anything that you want to discuss, please put it in the chat so that we will take up there and then we will have a discussion. So yeah, that's the thing, guys. So without wasting any time, just jump into this session. So today's session is on supervised learning for classification. Again, I will explain. Supervised learning is like we are training our model with the labeled data. Okay, we will say this is the input data with the label, and the model will train and will give the output. Okay, classification. Okay, so that is what we're going to learn. So I think most of us know what is classification, right? So if you want to classify, like I will say one thing. Okay, we are having a basket. Okay, in that basket we are having apple, mango, orange, pineapple, and then we are having carrot, beetroot, potato, baby corn, like those things. How you classify this basket? Based on the food, right? It is fruits and vegetables. Okay, this is what classification. That's it. Okay, we're gonna classify based on the feature. So that is what classifications, and it's gonna be a labeled thing, because like within supervised we are having classification. So supervised algorithm or a machine learning model used to categorize data points into predefined classes. Okay, so classification is a fundamental task in machine learning with the application in various fields, including image recognition, spam detection, and then medical diagnosis. I think you guys now have an understanding of, okay, like if you are getting a mail, whether it is a spam or not. If it is spam, it goes to the spam folder. Otherwise, it will be in the inbox. So like that, it is a real-time example for the classification, and we can have like for image recognition. Consider we are having an image of dog and cat. Okay, so that is a kind of classification, right? So whenever you are having, I'm not saying like it should be two, it can be multiple. Like consider we are having a image of 0, 1, 2, 3, 4, like that we will be having till 9, right? So we will be having 10 classes. So this is also called as a classification. So guys, anything that you can classify, right, and with label, then it is called as classification algorithm. Okay, hope you guys have understand this. So have a clear idea of what this is. Okay, whenever we are just performing some coding, we can have a very longer discussion on coding so that you can have a base understanding now, so we can discuss that. Okay, as sir is always mentioning, we are just doing a breadth search first, and then we will go depth. Okay, so yeah, over to you, sir.
Yeah, guys. So today we'll be going through the supervised learning classification. Okay. So supervised learning classification algorithms are machine learning models which we use to categorize data points into a predefined classes, and classification is a fundamental task in machine learning with application in various fields, including image recognition, spam detection, and medical diagnosis. So we use supervised learning classification for uh, image recognition. We use it in deep learning also, like and spam detection in emails, and medical diagnosis. Yeah, let's move to the other slide.
Yeah, sure, sure, sir. Okay. So what's the next thing? Okay, we're gonna introduce you the classification algorithms. So classification algorithm learn from the labeled data. We know that. Okay, to create a model that can predict the classes of unseen data points, they use various techniques to identify patterns and relationship within the data, enabling them to make accurate predictions. So guys, I will put it in a simple manner. There's gonna be some kind of formula. Okay, the algorithms are kind of formula that it's gonna have, and then based on that we're gonna predict whether the like whether the data points belong to first class or second class or third class, anything, what classification it belongs to. So let us see some of the algorithms, and we will just have a gist of it when we are learning or when we are building the models, right? Then we're gonna see this in very in depth. Okay. Now we go for a breadth first. Okay. So first we are having decision tree. Okay. So decision tree use a tree-like structure. Okay, where we'll be having a root node and then some kind of nodes, branch nodes, and then leaf. So based on the tree, it gonna classify. Okay. So it gonna do the classification. Whenever you just think of decision tree, consider the tree where you will be classifying different things. Okay. That's it. Then coming to support vector machine, it finds a optimal hyperplane that separates the data points within the different class. Consider if support vector comes to your mind, just consider we are having a line, just a line that classifies two things. So just have that. Okay. Then we are having logistic regression. It uses a sigmoid function to predict the probability of a data point belonging to the particular class. Okay, I will put it in a simple manner. Whenever you just think of a logistic regression, consider this as a S curve. Okay, above that we are having some value, below that there will be some value. So whenever you are having an idea of a logistic regression, the first thing that comes to your mind is that it should be a S curve. Okay. Next, neural network. Neural network consists of interconnected nodes that process information in layers, enabling complex classification tasks. So the thing is, if neural network comes to your mind, consider it as a bubbles. Okay, we are having number of neurons and we will do classification. That's it. Okay, so keep it simple because like we're gonna learn very in depth each and every algorithm. So decision tree, whenever decision tree, you just consider it as a tree algorithm. Support vector machine is still a line algorithm. Whenever you think of logistic regression, it's a S-curve algorithm. Neural network is like a bubble, so neurons. Based on that, it will do the classification. So have an understanding in a manner that um, whenever you just ask to explain, you guys need to explain. Okay. So yeah, that's what about this introduction to algorithms. Yes, sir. Over to you.
Yeah, so introduction to classification algorithms. So algorithms, we know that we need to have a single objective to input, output, and sequence, very clear sequence, uh, step by step process to solve any problem. So this is how we know what is algorithm. So here we have algorithms which are different algorithms with different objectives. Okay, so classification algorithms, they they learn from labeled data to create models. That is the first fundamental characteristics of a classification algorithms. And they predict the class of unseen data points. They are used to various techniques. They are used for various techniques to identify patterns, relationship within data, enabling them to make accurate predictions. Okay, so we have decision trees. So decision trees are different. We have different algorithms in decision trees, and decision trees use we use them like structures to make decisions based on series of rules, huh? We have multiple kind of decision trees. Okay, so then we have SVM, which is support vector machines. So support vector machines find the optimal hyperplane that separates data point into a different class. So you will be knowing the plane, it's hyperplane. So it is not on plane, but on a hyperplane, it separates data points into different classes. That is the work of a uh, SVM. Okay, then we have logistic regression, which is it is used. Logistic regression uses a sigmoid function. Okay, sigmoid function to predict the probability of data point belonging to a particular class. So logistic regression we use so this way in classification algorithms. And then we have neural networks, which is very deep. It is like it is used for very deep analysis. Usually deep learning is based on neural networks. So neural network consists interconnected nodes that process information in layers, okay, enabling complex classification tasks. So if you see DeepMind, it is built on neural network. So it will machine learning will do, let's say, 10 level uh, deep analysis for the data and find the patterns and get the insights. But neural network will go 100, 200 layer deeper. The the more the training you do in neural networks, it is said that the if you your salary zeros after one, how many zeros are there? It depends on how much deep level of training you do on data. If you do 100, 200, so those many zeros will be after your salary. So you need to learn these algorithms properly. Okay, so suppose when AI started, it started with a lot of errors and trials and errors for 70, 80 years. And then machine learning came into, different algorithms were invented, data was in process generated, and then now neural networks without data, neural networks, machine learning, or AI is nothing. So that is why learning deeply data science is very, very crucial, so that you can collect data, clean data, pre-process, do EDA, do ensemble learning, and lot of, you have to do all those steps, and then we'll go, we are doing depth for breadth for search, and we'll go into depth for search. So this is how you learn. These trees are used for, you have to know that structures to based on decision. We do decision based on series of rules. Okay, vector machines are used to find optimal hyperplane, which separates data points into different classes. Logistic regression uses a sigmoid function to predict the probability of data points belonging to a particular class. Neural networks consist of interconnected, interconnect. You can see bubbles here. So interconnected, and it these there are five, six, but they are like hundred thousands of layers. So they are interconnected. Like A to Z, we have limited alphabets, right? But how many books we have written? You can imagine that way. Uh, Neural networks, what magic they can do with like uh, 30 to 40 data set, they can do so much of magic. They can create so many patterns and so many insights and lot of permutation combinations. Okay, so these algorithms are very, very important. We need to learn them deeply, so that we understand how we'll use these algorithms for machine learning, and in future in deep learning also some of the algorithms will be using. So go and watch all the sessions deeply, 5 to 10 times. Do reinforced learning again and again, so that you can retain the concepts and information, and also go and do all the assignments, so that you will apply the concepts, and then you will get results. And write down in the comment section what have you learned, how you're going to apply, and subscribe to our channel, and also press the bell icon, so that you will get notification when new session is uploaded, and you will be in touch. So let us do it deeply. Let us learn deeply all these sessions, and then only come to this session when you complete 5 to 10 times the older all sessions. Do have patience, have vision for your life, and we are going to help you. If you have any feedback for us to improve these sessions, we'll be helping. We'll be there to listen to you, and we'll incorporate all your positive and whatever we can do in these sessions. So we'll be there, and at the end of these sessions, it's a year-long sessions. So you will get capstone you have to submit, and also the top three will get certificates and awards. Top three performers. So stay connected and keep learning. Thanks.
Yeah. So moving on. Okay. guys, this is what we have discussed. So binary versus multi-class classification. Okay, so classification problem can be categorized as either binary or it is a multi-class classification depending on the number of classes to predict. Guys, when I'm saying classification column cannot be one, right? At least two or more than two, that's it. Okay, so binary classification involve predicting one of two possible classes like spam or not spam. I'm sending a mail whether it is a spam or not spam. Multi-class classification deals with more than two classes, such as classifying different kind of um, animals or predicting the sentiment of piece of text. Okay, types of animals means we are having it will be like the dog, cat, rat, giraffe, like those things, lion, like those things. Whereas the sentiment of the piece of text, whether it is a positive sentiment, negative sentiment, neutral sentiment, or whether the person is anxious, or the person is enjoying, or it is in a happy mood, like those things we can say. Okay, so we are having two different types of classification. One is binary, another one is multi-class classification. Binary, we are having only fixed two different classes, whereas multi-class we are having more than two. That's it. Okay, these are the types that we are having for classification. Yes, sir. Over to you.
So binary versus multi-class classifications. Okay, so just a minute, guys. Just a minute. So classification problems, suppose whenever we get classification problem, okay, so we'll use we'll use categorical either binary or multi-class depending on the number of classes in the in to be predicted. Okay, so it depends on that how many classes we are uh, going to predict. Okay, so it depends on that. If it is lesser, like binary means 0 and 1. Multi-class more than that. Okay, zero binary is like 0 and 1, so and then multi is more than that, so it depends on that. So binary classification is involves predicting one or two, maximum one or two possible classes such as spam or not spam. So it's like 0 or 1, true or false, right? That way, spam or not spam. So then we have multi-class classification, which is deals with more than two. So that is the only difference. Okay, such as classifying different types of animals, predicting the sentiments of piece of text. So there will be a lot of sentiments, like 100 plus or 1,000 plus sentiments people will have. Mm, because a lot of people have different problems with the product and service. So if we are going for sentiment analysis, we'll have lot of emotional those things. Somebody will say, I I did not get my food on time. If we talk about Swiggy, so they're not delivered on time. Somebody will say the food was not tasty. Somebody will say they have not refunded me. Somebody will say the person was not on time. Somebody will say the quality of food was not good. So there we have multiple variables, right? In the So there we can use multi-class classification, and if we have one or two, we can use binary classification. Okay, thank you. Let's move to the other slide.
Yeah, sure. And then, guys, and one more thing: evaluation metrics for classification models. Okay, how we can know this is what perfectly happening for our model? Okay, when we train, so we need to evaluate our model, right? For that we are having different parameters. So evaluation metrics are used to assess the performance of the classification model. Yeah, they provide insight into the model, the ability to make the accurate predictions. Okay, what are the data set we give? We train the model. How we can test whether the model is perfectly trained on a data set using these metrics? First is accuracy. It says the overall percentage of correct prediction. So from the 100, like consider we are having 100 samples and then 90 samples are predicted, then it is called as accuracy. Whereas, what is the precision? Percentage of correctly predicted positive classes or cases out of all predicted positive cases. Only the positive samples. Like the thing is, if it is like consider we are having a patient have a cancer or not. The cancer having patient like yes is the positive class. how many positive classes is predicted as positive from that one. Whereas recall, this is a percentage of predicted positive class out of all the actual value, that is positive, that is yes, plus all the possible value, that is yes and no. Okay, then we are having effort score. It's a harmonic mean of both precision and recall, balancing both measures. Okay, I will put it in simple manner. We are having a data set for heart disease prediction, whether the person having heart disease or not. Yes, no. If we consider all the category, yes or no, and then in numerator and denominator, then it is called as accuracy. Precision is what? We're gonna find how many yes are there based on how many yeses. So how many yeses are predicted perfectly divided by how many total number of yeses. Recall is something which says how many yeses are predicted completely perfect divided by how many yeses plus how many negatives we are having in the data set itself. Okay, yes or no? Effort score is a combination of both precision and recall. It will say the harmonic. Okay, guys, please make sure that you guys understand this. Accuracy is the most commonly used. It uses everything. Precision only positive sample. Recall is also positive sample, but it takes care of negative samples also. Effort score is a harmonic mean of both precision and recall. So we will be using these things in order to evaluate our model. Okay. Hope you guys have understand this. Yeah, that's it from my side. Yes, sir. Over to you.
Yeah. See, evaluation. We have to evaluate the metrics for classification models. So for that we have parameters. So here are the parameters. So the what is the objective? We use to assess the performance of classification models with these four parameters, right? Uh, we it provides the insights to the model ability to make accurate prediction. That is the objective function for these parameters to these parameters will help us. So accuracy helps us to overall percentage of correct predictions. Okay, what is the overall percentage of correct predictions? Okay, and then precision is uh, it correct percentage of correctly predicted positive case out of predicted positive. So whatever is being predicted positive cases out of so out of that only the positive ones. So precision is used for that. Okay, so precision and accuracy, they both are different tangents, guys. Okay, and then recall is percentage of totally predicted positive case out of actual positives. Again, it is predicted positive cases out of actual positives. Again, it is the same thing, but it here uh, it is the same thing as precision recall. Okay, and then we have f score, which is harmonic means the precision and recall balancing both. Okay, so here we have to balance both. So that is the thing. Raja, do you think recall has same definition as precision, right?
Yeah, yeah. Actually, like only thing changes is in precision, we will take the positive sample, like how many positive samples are correctly
Out of
predicted by the model,
positives.
divided by total number of positive samples.
Yeah.
Whereas in recall, the number of positive samples predicted by the model divided by total number of positive samples plus total number of negative samples also.
Yeah, so what
That's
you
the difference.
do is, I think definition shows the same definition, but
Yeah,
in future we'll have that formula
yeah.
or some more explanation to it so that it differentiates. Okay.
Sure, sure, sure.
Okay.
Yeah, yeah.
Let's move to the other.
Yeah,
Uh,
the thing is, yeah, okay, okay. So as sir is mentioning, I'm just I need to just explain the things again. Like for precision, the percentage of correctly predicted positive class out of all predicted positive class, we are having positive that is predicted by our model divided by total number of positive classes we are having. Whereas in recall, say the definition, we are having percentage of correctly predicted positive class out of all actual positive classes. Okay, that's the thing. Okay, so guys, let us know if you guys have
yeah,
stuck
yeah.
anywhere.
Actually, yeah, I got it. I got it. It
Yeah,
is precision is precision percentage of correctly predicted positive cases out of all predicted positives, but
Yeah,
Recall is percentage of correctly predicted positive cases out of actual positives. Okay.
yeah,
So
yeah. That's the
there,
difference.
in precision, it is only from the positives, but out of positives, but in recall, it is the actual positives.
Yeah, yeah, yeah. That's the thing. Yeah, yeah. So yeah, guys, if you guys are stuck again in this, just ping us. Just put it in the comment.
Yeah,
Whatever the
it is
problem
in
you
the
are.
first go, guys. You will not understand these
Yeah,
at a meta level, but just absorb this. That is why first stage is to absorb and then digest it. And once you do reinforced learning, you'll go again and understand the concept, and you apply, you do all the assignments, and 5 to 10 times when you watch all these videos, you will build that muscle memory, guys, huh? Long term memory, huh? So it's very important to build that long-term memory. Short-term memory, if you do revision in 24 hours for all these sessions again and again, so you will build long-term memory and what you call muscle memory. So it will go into your body, not in your mind only, but in your body. But you have to do revision within 24 hours, guys. So when you do that, that is why 5 to 10 times is a best baseline for understanding something very deeply when you again and again do reinforced learning and absorb the information, then digest it. So first, don't think that how much you have understood, how much you have not. Don't judge yourself. Just go and absorb, do reinforced learning, and then you naturally understand it. So you will not put pressure on your mind to understand, but it will naturally come to you. So this is the process. Okay. So let's go to the other session.
yeah. We will go for the next slide. So, yeah. So we will be seeing one by one. Okay. So like we will today we will cover the logistic regression, somewhat depth. Okay. I will not say it is a complete depth, somewhat depth. Okay. Okay. What is logistic regression? So logistic regression is a linear model that uses sigmoid function, that is S curve, to estimate the probability of a data point belonging to a specific class. It's a simple yet powerful technology for binary classification problem. Okay, the strength of this algorithm is easy to implement and interpret because it is a S curve. Whenever the data points above the curve, it is considered as a positive sample, and below the curve, it is a negative sample. Limitations, there are a lot. Okay, it assumes a linear relationship between the features and the outcome. Okay, always it will consider the data point that you are giving in a linear relationship only. So whenever logistic regression comes to your mind, it should be a S curve, and the data points above that it's a positive, and the data point below that it's a negative. Okay, I don't want to say the formula. The formula is very easy: 1 by 1 plus e power minus x. It's a sigmoid function formula. So I think I've gone very faster. The formula is 1 by 1 plus e power minus x. It's a sigmoid function formula. It will create a S curve. Okay. Whatever the data points above the curve, it's considered as a positive. Below the curve, it's considered as a negative. Just have this theoretical understanding. Okay. Once we build a model, you guys gonna see there is only two lines of code. Okay. So have a clear understanding. Okay. So yeah, that's it. Not a big explanation for it. Okay. Yes, sir. Over to you.
Yeah. So again, guys, the logistic comes from the log. So log means we, what is log, logarithm and all. So when we have n number of, like, suppose we have 8, so we split that into different numbers. Okay. So that makes log, right? So logistic regression. So regression is a statistical method that tries to determine the strength and character of relationship between one dependent variable and series of other variables. So that is what is regression. So you need to understand the definition first. Okay. Then you will be able to understand, oh, why is what is it called logistic, and then you will remember also. So regression is always, if we talk about definition of it, so it is a statistical method that tries to determine the strength and character of the relationship between dependent variable and the series of other variables. That is why we call it logistic regression. And that is the fundamental objective of a logistic regression that helps us to like we use it. Okay, then logistic regression is a linear model that uses sigmoid function, okay, to estimate the probability of data point belonging to a specific class. It is a simple yet powerful technique for binary classification problems. Okay, so strength is easy to implement and interpret. That is the strength of a logistic regression. Limitation is assumes a linear relationship between features and the other outcomes. So you need to go, and whenever you want to learn new concept in life and you are not familiar or you are partially familiar, go and understand the basic definition of that particular thing and then combine it, or go and learn from the simple definition. First understand that, and then you will understand the formula of it. Okay, then you will understand math of it, but this is how you can remember it. So just absorb, and when we go for application, so you will understand that why it is. But there you are not going into deep into how, because that the process, the function is done by the Python and the Google Collaboratory. But here you have to understand these concepts at meta level so that we will know that what we are talking, what we are doing. If somebody asks, okay, why you are using logistic regression, why you are not using some other algorithm or some other method, so you should be able to differentiate, right? So you should know in and out everything about that model, what, why you're using, what you're using, and what is the objective function. Okay, let's move to the other session.
Yeah, sure, sir. So yeah, this is the thing, guys. This is what all about this session. So we got to see some more algorithms also in the next session. Okay, be curious. We gonna learn something different in the next session. Okay. So guys, as always, like we pass here, we will be continuing the remaining thing in the next session. Hope you guys have enjoyed the session. We have enjoyed a lot. If you guys have any doubt, just ping in the comment. So please go through all the sessions, like as sir is saying, 5 to 10 times, so that you can have a better understanding and come up with different questions, guys. Because like we know, okay, it is not we get everything in a day. It is always like a trial and error process only. Okay, so please watch all the videos, get the better understanding, and we will meet in the next session, guys. Okay, bye, take care.
Watch all the sessions 5 to 10 times, absorb the information, digest the information, and apply. Do all the assignments which are given, and only come to this session when you complete all the sessions 5 to 10 times. Then come to this session, subscribe to our channels, and press the bell icon so that you get notification, and also write feedback so that we can improve each session for you guys. We are here to serve you. Just give us feedback and write in the comment section how you are learning, how, what is your feedback, and stay focused, be patient, and continuous learning. Consistency is key, guys. If you're consistent for these sessions, continuously learning, patient, and have patience, so you will be successful. Thank you. Let's see you in the next session.
Bye, guys. See you in next session.